A pipeline welder with 15 years of experience walks into a certification booth, strikes an arc, and lays down a bead of metal that looks entirely bulletproof. But the inspector takes one look and rejects the test coupon instantly. The veteran has failed before the multi-thousand-dollar testing equipment is even powered on. Modern, high-stakes industries like aerospace and high-pressure pipelining rely on volumetric non-destructive testing. They use ultrasonic waves and X-rays to find hidden internal flaws, like deep porosity or trapped flag buried inside the metal. Yet the ANSI ASIS structural welding code mandates a rigid first filter. All welds shall be visually inspected. The logic is strictly practical. There is no point paying to X-ray an obviously flawed surface. This visual filter is brutal. In certain specialist maintenance turnarounds, up to 80% of test coupons fail, with surface-level visual rejections driving a massive portion of that fallout. This creates a strange paradox in the industry. The exact survival traits that make a welder legendary out in the mud and rain are the exact habits that cause them to fail a basic visual test inside a controlled booth. Out in the trench, a pipeline welder earns their paycheck by adapting. They bridge uneven gaps, burn through rust, and force poor metal alignments to hold together under terrible conditions. This is a standard welder qualification checklist. It dictates strict zero-tolerance requirements for base metal thickness, position matching, and preparation. A test booth strictly evaluates this fit-up, the precise mathematical alignment of the joint before any heat is applied. If a joint's gap varies by 1/32 of an inch, the required amperage drastically shifts. Leave the root face land too thick, and that blunt edge resists the heat input, dooming the thermal cycle before the arc is struck. Test booth preparation is a rigid equation, not a blank canvas. If a welder tries to improvise the starting variables, the structural integrity of the final product fails the math. Once the hood drops, personal intuition is replaced entirely by the WPS, the Welding Procedure Specification. This document is the absolute law of the test booth. Consider travel speed. Moving too fast to beat the heat creates a thin, weak weld bead. Moving too slow causes the sustained heat to overpenetrate, blowing a hole directly through the metal. Torch angle requires equal precision. If a welder uses a pushing technique instead of the required drag angle, they drive a wave of non-metallic slag forward, actively trapping voids inside the solidifying joint. Even the distance between the contact tip and the metal is heavily regulated. Holding the torch too far away stretches the arc and physically breaks the protective envelope of shielding gas. Without that shield, atmospheric nitrogen and oxygen instantly dissolve into the liquid steel, causing the surface to bubble with porosity. The muscle memory of veteran builds in the field is calibrated to constantly overcome bad conditions. Yet applying those same micro-adjustments in a flawless test booth actively manufactures defects. When the weld cools, the visual inspector does not bring out lasers or radiation. They rely on a pocket rule, a weld gauge, and a flashlight to read the surface. They measure for undercut, a specific defect where a groove is melted into the base metal at the toe of the weld. That narrow groove physically weakens the surrounding structure by concentrating all external load forces into a single fragile point. They also check for excessive reinforcement. A weld cap that sits too tall is an automatic visual fail. The extra mass adds unnecessary shrinkage stress to the plates, warps the metal, and inflates production costs. Trying to hide these mistakes is strictly forbidden. The AWS code expressly outlaws peening, the practice of hammering the metal to seal fine surface cracks on the root or cap layers. A visual inspection is a forensic reading of the welder's mechanics. Visible surface flaws provide mathematical proof that the underlying technique was incorrect. A veteran welder might argue their rejected coupon is still functionally strong enough to hold a pipe together. Modern engineering cannot tolerate that liability. Visual defects like undercut and surface cracks act as stress risers. Under repeated, long-term loads, these tiny imperfections are the exact locations where catastrophic fatigue failures initiate. High-stakes welding operates entirely as a highly controlled, statistically monitored quality assurance system. It is clinical and standardized. The rigid parameters locked inside a WPS are written in direct response to structural collapses and hard-learned historical lessons. To survive modern quality assurance, Welders have to unlearn their field survival instincts. Mastering the visual inspection proves absolute discipline, because if you can't pass the eye test, you will never survive the X-ray.